Hey there, Chenery students. This is Miss Moyer. Today's lesson is on 11.5, similar figures. I added a cartoon for you. Maybe you can come back to it at the end of the lesson and see if you understand it. So figures that have the same shape, but not necessarily the same size, are called similar figures. So in our picture over here, triangle ABC, this one here, is similar to triangle DEF, and we have a new cool math symbol to use. So in here, this little squiggle means similar. Two triangles are called similar when corresponding side lengths are proportional and corresponding angles are congruent. So corresponding means they go together. So for example, those two red sides are corresponding. The angles that have the same number of arcs, those are corresponding. So notice the angles have to be the same, but the side lengths are, there's that word, proportional. Okay, big 7th grade word. So for example 1, we're identifying similar figures. And I know if you look at this, you can tell pretty much right away which ones would be similar and which ones wouldn't. But we need to remember for similar figures, they need to be the same shape, but their size needs to be proportional, which really means their sides. So for example, if we were to compare A to B, for the red side lengths, its ratio of sides is 3 to 2, and their blue side lengths have a ratio of 6 to 6, which reduces down to 1 to 1. If we were then instead to compare rectangle A to C, you'll take a look at the red sides. We've got 3 to 2 as their ratio. And for the blue sides, we've got 6 to 4, which reduces to 3 to 2. So you'll notice that when we look at A and B, they are not, those side lengths are not at the same ratio, not proportional, because 3 over 2 is not equal to 6 over 6. But over here for A to C, 3 over 2 is equal to 6 over 4. So that's a yes. So A is similar to C. Okay, for example 2, we are told the triangles are similar. What that's telling us is their side lengths are proportional. So we can use a proportion to figure out the missing side x. We just have to make sure we're matching the corresponding sides. So if we take a look at these triangles, this side and this side are proportional, are corresponding. So we can make a proportion out of them. So we know that 6 is to 9 as 8 is to x. And when you look at this at first, there's no easy mental math strategy to deal with it. We could do cross products right away. That's one option. Get us the answer. So we get 6x equals 72. So x would equal 12. If we wanted to be a little crafty, we could say, look, we can reduce 6 over 9 to 2 over 3, and then use our mental math strategy to say, hey, 2 times 4 equals 8, 3 times 4 has to be x. Another way to prove that x is 12. And remember, it has units, so these answers, either way you go, the answer should be 12 meters. And a quick side note, just because I set my proportions up for like 6 to 9, it's not the only way to set up the proportions. I could have also done 6 is to 8 as 9 is to x. That would also work just fine. You'd end up with the same answer. Okay, here are the on your own practice problems. Would you please pause the video and then try these out? And when you're ready, unpause the video and you can check your answers. So I started, first part of the answer is just the proportion you need to set up. Make sure your proportions are good. And I went ahead and solved those two proportions. The answer to number 2 should be 4 feet. The answer to number 3 should be 24 centimeters. Okay, time for your assignment. Page 498, numbers 4 through 5, 8 through 13, and 17. If you have any questions, email me or Mr. Golden. Have a great rest of your day.